Structuring projects. Structure of C++ projects. So what is project structure really? In this video, by project structure, or to be more specific, by physical project structure, we mean how project files, folders, and deliverables are organized. And the structure includes not only your code, but also how the third-party libraries are managed. There are many ways to organize a C++ project, and there is not really the single right one. Just like there is no perfect architecture for each project, there is also not a perfect project structure. Yet, project structure is very important. Why is that? Well, because every project grows, and as the project grows, its structure makes it easier or harder to continue. Poor structure is going to create problems, such as, for example, increased compilation times, and also refactoring of poorly structured projects is expensive. When just starting with a project, say before it reaches 1000 lines of code or so, structure is not really important or doesn't seem important. That is, until the project grows a bit, and then because of the poor structure, it's already harder for new developers to join and find their way around the files and folders. And we will see how project structure affects compilation time in a few minutes. Compilation time becomes worse and worse. And when a project matures and reaches a point where not a single developer can possibly know all the details about it, it becomes virtually impossible to refactor it. Compilation at this point can take hours, and the bigger the project is, the harder it is to create a good structure. This is why it's important to start with a good structure from the beginning. And then you're going to get a lot of benefit because it's going to be easier for new developers to explore the code. The names are going to be clear and the files are going to be easy to find. It's going to be easier to extend code because every developer is going to know where the new files, the new classes have to be physically placed. It's also much easier for developers to collaborate when the project is well structured, because you would avoid merge conflicts, and it's also going to be easier to separate responsibilities, avoiding too many people committing in the same file. Good structure promotes modularity of your project, and if a sister project, let's say, needs parts of the same functionality, then if your project is well structured, it's going to be pretty easy to extract it into a shared library and reuse code over multiple projects. Going back to the first point, structure is a form of documentation. The better a project is structured, the easier it is to find your way around the code. Probably the most important rule when thinking about how files and folders are structured in a project is that physical structure is not a thing on its own. A physical structure should always reflect the internal logic of the application, that is, how classes and namespaces and components are organized. Applications are, of course, structured on multiple levels. At the very top level, we would see the application as a whole, or maybe a large subsystem or a service. And each of these is going to consist of smaller units, which in this course we're going to call packages. And every package consists of even smaller units, which again in this course we're going to call components. An example of a component is a class in two files, namely a header file and the corresponding CPP file with implementation. And the main unit of project structure is, of course, a package. So a package, once again, is probably a folder containing a few headers with a few C++ files, and a package is typically responsible for a small part of your application. Implementation of the package, unlike the public headers, is not visible from the outside. Packages depend on one another, and dependencies should really be under your control. One thing that should really be avoided is circular dependencies between libraries. What do I mean by that? Look at the red arrow here. So if there is a dependency from package A to package E, then we get a cycle from A to E to D back to A. What is the problem with that? Well, imagine that each of these packages is actually built into a shared library. It's no longer clear for the operating system then in which order to initialize these shared libraries, and that's just one of the problems. And to be honest, it's really hard to justify the split up itself. Why would these parts of code be split if they are all interconnected? And it's so important that actually the C++ core guidelines include a section about this. Until this point, we talked about the project structure in general. Now let's finally get talking about C++. Elements of structure in C++ would include, obviously, header and source files, as well as directories and some supporting files, such as resources or maybe documentation. A class would often be split into two files, declaration in the header file and implementation in the CPP file. When doing that, it's important that the file name matches class name, because then it's much easier to find your way around the code. But also, don't make this a part of your C++ guidelines. Don't do this for every class. Otherwise, you would end up in a situation where you have many tiny files, and it's going to be somewhat hard to maintain. Even the C++ core guidelines include a point that placing each class into its own file is not a rule and not a guideline. Classes, of course, can be grouped in namespaces, and the C++ core guidelines do recommend splitting your projects into separate libraries to promote code reuse, of course.